Okay, so today's lesson is over function notation, and we're going to throw a little discrete and continuous functions in there too. Now, let's see if I can use my magic pen here so we can kind of follow along. All right, a function can be thought of as a rule that assigns one output to one input. All right, and this is going to help us when we do domain and range a little bit later. All right, now this right here, this f of x, that's actually the name of the function. This means the function of x. And believe it or not, this is actually one of the earliest computer programs. Okay. What's in here tells us what number to plug into the function. Okay. Now, what this actually means is f of x means the output of the function f when the input is x. So, f of x also is y. And this is the function rule, or, that's the rule that it has to follow. So whatever you plug in to here, whatever we plug in here goes here, and it obeys these rules, okay? Just some fancy words, nothing really big. If you need to write this down or go back, you can pause at any time or go back and look through. All right, so what we're going to do now is this is actually this right here. This is the function notation, okay? This says find f of 1 and f of negative 2. All right, so what this means is when I want to erase that. Let's do that one in blue. Okay. What this means is we're going to say when x is 1, what is our y? So I'm going to plug this in. Honestly, this is a calculator problem. If you put this into the calculator as it's stated, you'll get the right answer. Okay, because 3 times 1 is 3, plus 4 is 7. Okay, that's our answer there. Here, when x is negative 2, what's y? All right. So this gives us negative 6 plus 4, and we get negative 2. That's really all this is. All right. Now, this one we have two different functions. All right. Now, it says f of x and g of x. It could be any letter besides I or O, and that's because it's confusing. And I is used for something else. We'll get to that later this semester. But, basically we're just finding out what the y value is for these functions given an x. All right, so f of 3. So get my calculator here. So I'm actually going to plug it in as it says, in with parentheses. I'm going to square it, then I'm going to add 3. All right, I'm going to get 12. Now, for this one, because it's G, I've got them color-coded. That's just the way I roll again. So we're going to plug in 3 here. Negative 2, parenthesis 3, close it, minus 5. All right, we get negative 11. Okay. Now, this is why it's super key, I believe. Everywhere there was an X, I put parentheses, because if I plug in this negative 2 and you plug it into your calculator or type it in your calculator as it's written, you're going to get the right answer every time. Okay, because it's a simple machine and it will follow the order of operations. All right, we get 7 here. And this plug in 0, well, I'm not going to use a calculator because this is going to cancel out. And I'm just going to get negative 5 here. All right. Now, find the range given the domain. We're going to go a little bit more into this later. But basically, here's your functions. All right. So I'm going to do one right here. I'm going to just plug in, negative 2. All right. Now, I know I'm going to write stuff in braces, and you don't have to really worry about that because you're not going to be writing anything unless you're writing notes. So negative 2 squared minus 4. All right, we get 0. Yep. All right, so I've marked that one out because I've got it done. And I'm erasing because I want to. All right, now I'm going to plug in 1. Okay, now I could do it in the calculator. I'm not for this one because, 1 times 1 squared is 1. 1 minus, so negative 3. Okay, and nope. Okay, so 1's done, and then we're going to do 3. Well, 3 squared is 9. 9 minus 4 is 5. All right, now if we were in class and you wrote these like this, I would be totally fine with it. Okay, because you're writing them down in the order that you got them. That's totally cool with me. Now, what you will see on standardized test is that they'll put them in least to greatest order. Okay, just like that, and it's not really a big deal. All right, but either one, if we are in class, I'll accept this. Other places you'll see it like that, but don't let the order confuse you. Just make sure that you got the right numbers. All right, same thing. I got negative 2. Well, this is negative 6. Okay, minus 4, that's negative 10. So I'm going to, well, I thought it was going to erase. Why did it's doing all that now? Still learning the pen. I know, 3 weeks into it, you'd think I'd have more practice, but hey, it is what it is. All right, 0. Well, that's going to be easy. That's just going to be negative 4. All right. And the reason I'm not writing them out over and over again is because this is calculator work. So all you have to do is just plug these in and make sure you plug them in the right spot because I couldn't see that time. Okay, so 3 parentheses 13 minus 4. Yeah, I know I'm a math teacher and I should be able to do that in my head, but I can't. I'd rather do the calculator. All right. So there's what it is, and we use function notation for this. Okay. All right. This is where it gets a little bit tricky with these absolute value ones. I don't think I have very many or any of these on your homework because they get kind of confusing. But let's just step through it. All right, so I'm plugging in negative 2. All right, this part first. This, we have 4 minus negative 2. All right, that gives me 6. Remember, absolute value makes everything positive. So I'm good with that. Where it gets tricky is when we start plugging in other stuff. Okay, so like for this one. All right, we have 4 minus 5. Well, that gives us negative 1. We still have to take the absolute value of that. We got to do what's inside first, and then we take the absolute value. Well, the absolute value of negative 1 is 1. All right. And then 8, 4 minus 8, well, that's negative 4. The absolute value of negative 4 is 4. Now, notice I didn't do my calculator a lot with this one. Unless you have a calculator and that you know how to operate really well for the absolute value, it's not going to be your friend, okay? Go back, pencil and paper. Now, I'm not really worried about this per se on like homework and the test because coming up in Unit 11 or 10, I've got to double check, somewhere later down the line, we will actually do this, okay? Now, the square root function right here. Now, this you can actually plug into the calculator. You just have to make sure everything's underneath the square root. And normally, I would go around and show you how to do it because I want you to know how to use your calculators. And if there's a need for me to show you how to do that, I'll make a video on that. But until then, we'll cross that bridge when we get there. Well, -1 plus 5 is 4. Square root of 4 is 2. All right. So we move on. All right. So now we have 11 plus 5 is 16. The square root of 16 is 4. Now, there is a reason why these numbers are like they are, because we want them to be, when we designed this years ago, we wanted them to be perfect squares so we wouldn't have to deal with decimals, because we used to have you graph these, and you can't really graph a decimal correctly. All right. And 76, well, 76 plus 5 is 81. Square root of that is 9. All right. So that's kind of how you would go from there. Again, not worried about these. I just want to show you these, okay, as much. Just these are like extra practice, okay? So if you're really worried about this, we can do a one-on-one session or a small group on WebEx, and we can clarify this, but don't let these two examples really throw you off. Okay. Continuous and discrete. A continuous graph is something that's unbroken, and discrete is like distinct isolated points. All right. The big thing I want you to know about this is that when we're looking at these, we're looking for whole things. Okay. Whole. Now, there is a link that was down here. I could show you, but I'm not really worried about that. You can actually Google that if you want to. All right. Now, we really have to think about if something can be a whole or not. So in this part right here, it says identify the following variables as discrete or continuous. All right, number of telephone calls received. All right, how many calls did you get that day? That's how many calls you get. All right, that is a discrete. All right, the length of or the weight of a bag of nuts. Well, even though it's going to be different types. It could be 1 pound, 2 pound, 3 pound, 4 pounds. Okay, this one would actually be continuous. All right. The length of a piece of wire. There's a start and there's a stop. This is discrete. Okay. The speed of a car. Now, this one's very vague. I don't like this per se. All right. But think about it when you get in a vehicle. The speed changes. Okay. Even if you have it set on cruise control, it changes. So it's continuously changing. All right. The number of speeding tickets given in a town. Well, if it's Madison and it's the end of the month, they may be making sure they get their quota. Discrete. Number of flaws in a bolt of fabric. A bolt is a measurement of fabric. I don't do that. My wife does. Now, one of them may have 5, one of them may have 6. We don't know. Okay. So, and that's not going to be set every time. Population of a city. Now, this year is 2020. I know some people think it's a bad year. Personally, I've had a great time this year. Population of a city, that's going to vary. Babies are born all the time. People end their time here. I would say that's kind of continuous. I hate it when I see signs that says population of this time, because that's at that moment. Okay. And this is one of these, it could possibly be discrete also. All right. And I'm not a big fan of this. These are all very vague. I'm not a vague person. All right. A person's age. All right. So many years, like I'm 40, or you could say technically I'm 40 and 1/4 or something. I would say that's discrete. Okay. Now here's the bad thing. Some of these are always up for discussion, and you can also, say, but what if? The ones that I would really kind of focus on is like stuff that's a whole, like this one. To me, this is a better example. Okay. So we had to kind of think on that line. All right. So like this, it says, tell whether the graph is continuous or discrete and find the answer to the question. All right. The cost D in dollars for a parking pass depends on the whole weeks. That right there. If you remember back here, it says whole, discrete, whole number of weeks. Okay. So this one's going to be discrete. All right. So that's the first part. Now, how much would you pay for a parking pass for 8 weeks? Well, this is a function notation. Okay. Now this has D of W because it's, dollars and weeks, and people got fancy with it. I'm not that fancy. All right. 25 times 8. That should be 200. But I'm just going to double check myself because I want to make sure. I don't want to mess up. Yeah, it is 200. Now, some people may think that's crazy, but in some of the larger cities, I knew somebody, they lived in New Orleans. They paid for a parking place. They had a parking spot like really close to the stadium down there, and they paid per month for that, but they paid a lot for that parking spot. Okay. All right. So same thing. Price speed, apples depends on weight. All right. Now, the way to apples, it's not the whole number of apples, the way to apples. Now, this is where you need to ask yourself, can you have a half pound or does it say whole? It does not say whole. Okay. This one would actually be continuous. 10, and good thing that the word is right there because, spelling. All right. And we're going to plug it in. This time, you would put 6 right here. I'm only going to do this right here because that's what you would do as a student. And that should be close to 12. Yeah. And so you're going to pay $11.94 for apples. I don't like them apples. Sorry, I laughed. All right. Now, represents the area of a square with side length x. All right, on a square, can you have half of a side and still be the whole? All right, this is a whole length. All right, this is a whole. Okay, so this one's going to be discrete. All right. What's the area? 5 inches. Well, that's 5 squared. That's 25 inches squared. All right. So, and we're done. Now, if you're worried about the continuous and discrete, it's okay. Don't over focus on that. Main thing is, can you plug something into a function or a formula and get the right answer? All right. Again, don't let this whole continuous and discrete thing bother you. All right.